Hi everyone, welcome back. Today we're doing count prefixes of a given string. We're given a string array words and a string s, where every single word and s comprise of only lowercase characters. And we have to return a number of strings in words that are a prefix of s. So every word in words are potentially a prefix of s, and we have to count the number of strings where that is the case. And for our viewers who are new to the terminologies, the prefix is a substring that occurs at the beginning of the word. So if you have a, because this word over here starts in s as well, then a is a prefix of s. But in this case, for this character b or string b doesn't start at the start of s, so b is not a valid prefix of s. And the substring is a contiguous sequence of characters within a string. So these are like incomplete strings inside s. So for the first test case, notice that we have three words that are valid prefixes in s. So they are a, ab, and abc. For the second example, both a's over here are also prefixes in s, so we return 2. For the constraints, the words range from length 1 to length 1000. Every single word as well as the length of s, in this case, range from 1 to 10. So that's pretty lenient. And finally, every single word and s consists of only lowercase English characters. So we don't have to worry about lowercasing or anything like that. So to solve this question, we can do a linear scan across words. And for each of these words, we just check if s starts with this word. And if that's the case, we will increment it by 1. So with that, let's quickly go through a simple test case. So let's say words is equals to this and s is equals to abc. So we will keep track of a variable. Let's call this count prefixes, and this will be equals to 0. This will be used to keep track of valid prefixes in words. So for word in words, we will just check if the current s starts with word, then in this case we will increment count prefixes by 1, and we will just return count prefixes. So for this test case, let's try tracing this out. So count prefixes equals to 0, word is equals to a, the first item in word, and in this case this will be true because s indeed starts with a, and in this case we increment count prefixes by 1, and we will continue this tracing. In this case b, this will be false, so we leave count prefixes unchanged. Word is equals to c, this is still false because s doesn't start with c. Now we reach the fourth item, ab. In this case this is true because s, which is abc, indeed starts with ab, so we increment this. We have bc in 0, 1, 2, 3, 4, 1, 2, 3, 4, 5th position. In this case, this will be false. Count prefixes remains unchanged. And now we're at the final item, abc. In this case, s, which is abc, indeed starts with abc, so this will be true, and this gives us 3. So that's pretty much it. So the tracing went well. Let's start implementing this. So count prefixes equals to 0 for word in words. If s starts with word, then count prefixes plus equals 1, return count prefixes. So let's check this through. We initialize the variable to keep track of prefixes. We do a linear scan from left to right in words, and we check if the current s starts with the current word that we find. So if that's the case, we increment count prefixes by 1. Looks great. Let's run this against some test cases. I might have made a mistake, did I? Yes, I think it means starts with. Yes, it's meant to be starts with. The with in this case is not a capital letter. So yep, this works. Let's submit this to test this against other test cases. And this passes. So in this case, the time complexity is on, because where n is the length of words. So if the number of words scale linearly, let's say words is now 10 words, then we will do this comparison 10 times. So space is on. For space complexity in this case, like we do not use any copy of words or s in this case, so space will be O1 over here. So that's pretty much it for this question. If you find this useful, please give us a like and subscribe, and we will see you in the next video.